So today I'm going to talk about HTTPS, now you see me, now you don't. And basically that's an SSL strip attack, and I'll go into detail about what that is and stuff like that. So who am I? I'm 17 years old. I'm a cyber defense analyst at Mullican Technologies. I'm a junior at Laurel Springs School, and I'm doing well at Calhoun Community College. I have several years of experience with Linux, a bunch of OSs, programming languages, and cybersecurity. And I hold several IT certifications such as the CompTIA, Security Plus, Linux Plus, Mobility Plus, the EasyComp CDH, the Linux Professional 2 L51, the Certified Linux Administrator, and the Microsoft MTA Security Essentials and Microsoft Certified Professional. And then we're going to talk about SSL strip, there'll be a short demo, and then there'll be a summary. So some background information first. This is a list of common cyber attacks over here. And you see right here, viruses, malware, worms, trojans take up about 50% of common cyber attacks. Specifically, the area that we're going to be talking about today is in the other category, which is 11%. And another interesting side note, more than 600,000 Facebook accounts are compromised every day. And an estimated annual global cost of cybercrime is over $100 billion every year. So, what's the address here? Some of you might say the room number. Some of you might say the college's building identifier. Some of you might say the street address. Some of you might say the phone number. All of these are technically correct, but the usefulness of each answer depends on the intent of the question. If we intend to call somebody, the street address or room number are useless. Computers are the same way. They have multiple addresses, each with a different purpose. First is the MAC address or hardware address, and that is on the physical layer, which is the NIC card in the computer that you have. The second would be an IP address, which is used by the operating system and software. And finally, we have a host name or domain name, which is basically your name tag. You know, when you go to Google, that isn't really, it translates into an IP address such as, 192 or 198.16, so on and so forth. And basically, they do that just, it's easier to remember Google instead of an IP address. Let's continue. So here is a basic image of an ARP request and the ARP protocol. So right here we have our computer, and this software says, I want to know how to talk to Alice or Bob or whoever. So basically he sends out an ARP request that says, here's my IP address, here's my MAC address, and he wants to know where's Alice. And of course the hardware NIC card doesn't understand what an IP address is. So the program that correlates between an IP address and a MAC address is what we call ARP. And ARP basically just says, I want to know that MAC address is Alice. So it says, please Alice respond. And then right here in the ARP response, we have Alice saying that, okay, I'm Alice, and here's my IP address, and here's my MAC address. And one of the problems with ARP is that there is no verification in place. So for example, if we have Bob and Alice talking, they know that, Bob knows Alice is at MAC address AAAAA, and Alice knows that Bob is at MAC address BDDD. What if our attacker, for instance, Ben, says to Bob, I'm Alice. Now, Bob has no way to verify that Ben isn't lying. So this is the basic premise of an ARP spoofing attack. So right here, you'll just send an ARP response saying, hey Bob, I'm Alice, and my MAC address is right here. And one of the important features about ARP is that a computer will catch an ARP response even if it did not send a request. So this is useful, say in an example in an office environment, we have Bob hearing that Alice is, at Office 105. And, he didn't ask specifically for the address palace, but since he heard it, he's going to catch it anyway and make a note of it. So, some common ARC poisoning tools. I personally would prefer Linux. I'm a command line geek, I guess you'd say. Specifically, EtherGap and ArcSpook would be one. There's also ArcPoison and THC Parasite. On Windows, a very good one is Enable. That's just a general multi-purpose hacking tool with APR that they call it, specifically for ArcPoison requests. On Android, there is Droid Cheat, ArcSpook, and SSL Strip for Android. And one of the critical things about Android, I believe you have to have a root phone, but you can actually run the attack that I'm going to run on my computer on the Android operating system, thereby having a completely mobile way to get usernames, passwords, credit card information, whatever you have. So here is a explanation of SSL. So SSL provides a secure way of transferring data across the internet by encrypting it. So for instance, if we have on a website, we're entering our credit card information or using our password to order pizza or buy something off Amazon. We don't want this sent over to clear text where anybody just sent in the network can read it and get our username, password, or credit card. So SSL was implemented as a way of point-to-point encryption, so a normal user just sniffing the network would not be able to read it. Some common vendors that offer SSL certificates are DigiCert, GoDaddy, VeriSign, and Komodo. And right here is a list of the top provider statistics for the top 1 million sites. And you notice this big gray area right here for other. That basically means it's a self-signed certificate. So for people who don't want to pay anywhere from $30 all the way up to thousands of dollars, or they just believe that a signed SSL certificate is of no use to them, they can make that themselves for free. The only downside of this, which you all probably seen, is it pops up the big warning box that says, warning, this is a self-signed certificate, and it's got the big warning letters in a red box, I think, on Chrome. Some of these other ones, GeoTrust, Komodo, GoDaddy, RapidSSL, those all are cheaper certificates, and that's why they're the most popular. Those cost only from $20 to probably $100. And then as you keep going down smaller and smaller, each one of these costs more and more, it looks like. So when you get down to like Symantec and GlobalSign, these are thousands of dollars each. And the reason for that is because you get a certain level of warranty. So with GlobalSign right here, I believe if you purchase however much it is, they give you up to $3 million warranty if somebody hacks your site and it's not your fault, it's the SSL certificate. So that would be why most companies like Amazon, eBay, they all go with something like Symantec or GlobalSign, Dot. Those are a few big ones. So here's a SSL process. First, we have the browser connecting to the site with SSL. And he basically connects to Amazon and says, hey, I want to communicate encrypted. Then the server basically sends back his SSL certificate with his public key. And basically, the public key is sent to everybody. Everybody can read it. It doesn't matter if they have access to it. The private key is stored only on the host. You do not want anybody having a private key. If they have that, they can decrypt your SSL traffic. Third of all, the browser performs multiple checks. It checks if the certificate is valid via a certificate relocation list. And all that does is basically checks, is this certificate valid? Has it been revoked by the digital authority that signed it? So say somebody gets my private key, and I'm afraid they can decrypt all my traffic. I don't want unsuspecting people to have their information compromised. So I send a letter to the certificate authority saying, I want your certificate revoked. I think somebody's hacked my server and gotten access to the private key. Now anybody who tries to use that certificate will get a warning box that says this certificate is not valid. And if it turns out the certificate is valid, it'll create a session key that it will encrypt with a certain public key. Now the only machine that can decrypt this decrypt this session key is the server private key. And basically, all this means is the web server and the browser is communicating and encrypting data between each other to make sure they are the true hosts and nobody's trying to perform a man-in-the-middle attack using self-signed certificate. Fourthly, the server decrypts the session key using its private key and sends back acknowledgement. So basically, now they know they're communicating together. Nobody's trying to mess with the traffic in between. It's the true intended host, and everything's fine. So this process is great, and the main attack that I'm going to be featuring today is SSL script. It's a program, and what it does is, with most of the man-in-the-middle attacks, and what that basically means is, I have, machine A right here, and I have machine B, and they're trying to transmit securely. So, I'm going to Amazon, but let's say there's a machine C in the middle, and he's trying to sniff traffic in between A and B. So he's like, I'm going to be the man in the middle. I want to steal your username and password. The problem with this is the SSL certificate will now appear as invalid because the attacker can't spoof the SSL certificate, so we'll have to create a self-signed one. And one of the disadvantages of that is you'll get the self-signed error. Right here, you'll see since the victim session is no longer secure because SSL script has essentially stripped the connection, we will no longer get any warning boxes for self-signed certificate errors. So this basically alleviates the need to try to crack SSL, try to steal a private key. We basically just let's take SSL completely out of the equation. Let's just make it non-secure traffic only. The user will probably not notice this unless they're tech savvy, and they'll probably just continue like nothing's happening. So they'll get no warning boxes, it'll look completely normal. And once we have this attack, now we can capture all the secure fields that were secure before unencrypted. So now we can be using it as passwords, credit card numbers, whatever you enter on a typically secure form. And also, one interesting thing that you can do as part of this program is you can change the favicon. Basically, what the favicon is the little icon to the left of the URL. So for Amazon, it's the orange A box, I think. For eBay, it's the E. You can change that to a picture of a lock, and that would trick a untechnical savvy user into keeping the site secure. And also, they'll see words on the page. If you go to US Bank, it'll say secure. All of these are little things that will trick the user into believing that they're on a secure site. In fact, they are not. You can download SSL script here. And here's an example. So right here we have Amazon right here. So you see, here's the background I was talking about today. It's right down here also. Everything looks secure. We're all good. HTTPS. Now notice the difference between the SSL script and hack. Right here, the favicon has been changed to a picture of a lock here. Everything's the exact same, except the HTTPS has been changed to an HTTP. How many people would notice that if they're not technical and weren't looking? And here's another example for US Bank. The only difference here is since it's an extended validation certificate, and all that really means is just they went through extra checks with their certificate authority to verify the right entity, and that has allowed them to change to R3. So that's an extra level of security that most people would see. Now the only difference between that and our SSL script version is the bar has been turned from green to white like it should be, and it's unsecure and favicon changed. So overall, not much difference still. Here's some statistics. This is from the original talk that Moxie Marlins gave at 2009 Black Hat. He's the one who actually invented this tool. And he said in a 24-hour period, he was able to obtain 300 miscellaneous logins, 117 email accounts, 16 credit card numbers, and 7 PayPal logins. Now that's a very high number, and I'm sure if we perform this kind of statistics today, it would still be close to this. And here's an example. Right here, this is a simple tool. We can go download it. It's probably hard to read, but basically I just say single opt attack, single host. I'm going to use interface, the default interface. Here's my target, the gateway, so how I want to get my password, which is password, and here's the URL I tried to get. That's as simple as. You can do it in less than 2 minutes with this tool. I mean, you can also run the command manually, but I would just automate the process. It's much easier to use. Here's an example of Cisco. You could log in. We're going to log in with test@yahoo.com. Password 123. This is the thing pops up over here, new account found. I show, and it says up here you use the username test@yahoo.com. Password is password 123, and there's the URL. And I think I'll also repeat this process for Amazon, eBay, and Gmail, just to show a variety of hosts and vectors that this will run. So you can do this on, guest wireless. You can do this anywhere really. All you have to know is the interface which to use. So basically, that's usually E0 by default, and you have to know the IP address of the host you want an SSL strip, or you can do it for the entire network by building that support. And you have to know the gateway, so how the traffic is routed to the internet. And usually that is 192.168.1.1. That is the default gateway for most all routers. So really, it's that simple. Inside really. I did it for accountants Blackboard. I did it for if you want to get really insane, I guess I did it for Intuit's online payment managing. I did it for healthcare.gov. Really, any site you can do this for. And you just keep scrolling up this right here. And you can download this front end on my website. I'll post a link to it. But now let's go over a summary. So what did we talk about? First, we talked about ARP. What does ARP do? It translates IP addresses into MAC addresses. And why is this useful? So say in an office environment, we have Bob and Sally, and Bob wants to know what Sally's IP address is. So ARP translates between the two, and it says, Alice responds, and Alice responds back. So that's basically what an ARP reply and an ARP request are. Second, we have SSL. What does SSL do? It's used to encrypt the traffic. So we want to have a way to securely communicate all of our data onto a field and on a web server. And what does SSL strip do? SSL strip basically strips the secure connection, so we don't have to worry about any kind of warning boxes, any kind of errors with an actual SSL man-in-the-middle attack that we usually have to worry about. So we just create all of that, and it's combined with the ARP spoofing attack. So we basically just say, I'm the way out to the internet, and then I forward it onto the actual gateway. Therefore, I am a man in the middle. I am between you and the gateway. I forward everything onto the gateway, and then now I have access to all your usernames, passwords, everything that you would normally see. Where can we go from here? There is 2 attacks I'm going to focus on right now. One is a fake access point attack, and another one is an evil twin access point attack. And what are these? Essentially, in a fake access point attack, what we do is we set up a wireless card to act as a wireless card. So we basically say our wireless card on the computer, we're going to set that as a free wireless call, HTTPS Wi-Fi, or free Wi-Fi, or something like that. And then our unsuspecting users are going to connect. They're like, oh, free Wi-Fi, let me go browse the web. Now, what's nice about this attack is we can build an SSL strip, and whatever kind of attacks we want to do, like, say we want to inject JavaScript in every page they visit, or, make them download a file, an executable file every time, or when they first log on the network. We can do any kind of attack that we would want to do. And the only difference between that and the evil twin attack is we jam a legitimate access point first, and then replace ourselves as the So, say you're at Starbucks and there's an HTTP Wi-Fi already there, we're going to jam them, and then we're going to put ourselves as HTTP Wi-Fi, and everybody that's on the original one is going to connect to us, plus anybody else who wants free Wi-Fi is going to connect to us. And we can do the exact same thing. We can, get people to connect, we can have them, go to the web, they can download a file. Really, the possibilities are endless for what you can do once you already access it. So some countermeasures. The first countermeasure is HTTP strict transport security, also known as HTTPS. And what this basically says is, the first time you visit the site secure, I'm going to place a cookie on your machine locally. Basically, a cookie, it just stores a piece of text, a piece of data that the website uses. And it says, I want to make sure anytime I visit this site, it's secure. And it means that this cookie will last up to a year. And one of the nice features about this is the SSL strip attack happens between the web server and us, whereas HTTPS is happening on our local machine, so there's no way we can bypass this. Basically, it'll force the local machine to go to the secure site, and there's nothing we can do about it. The second mitigation is manually having an HTTPS instead of HTTP. If you have, secure bookmarks, that would support it. But most people, they just type in Google.com or, Amazon. They don't have a lot of typing in HTTPS:// mail.google.com. And basically what happens when we first go to that unencrypted Google, now any other site we visit, it'll basically strip the secure link in place of an insecure link. So now anything we search from that Google page will be non-secure. There's also an application called ScriptGuard on iOS and Android, ArcWatch on Linux, and Concatenate ID is another one, I believe. I tested out that one. It's a pretty nice proof of concept tool. It just alerts you when the gateway MAC address changes, which should basically alert you that something's wrong. So here's some contact me information. Here's my website. Like I said, the tool that I made will be on there. You can go download it for free on GitHub. I think I also have a zip file of it. Here's my email if anybody wants to send me an email. And here's my LinkedIn.
Recommendations on hardware for using the Eagle Twin that you use for that?
Hardware, it's probably like an alpha. The only downside of an alpha is it's USB connected. That's external. I think you can even do it like an internal router or like an Intel, but with the alpha you're going to get greater range and more output power and stuff like that. My parents are both Linux system administrators, so from a young age I was introduced to the computer world. Actually, the way I got my first certification, my mom, or actually my instructor at Westminster Christian Academy, told me about a security class, a certification class at UAH. I signed up for that in August of 2012. That's when I've been. Eventually turned into my internship and then my job at a later. And from there I got my CEH, Linux Plus, Mobility Plus, Linux Professional Suite L1, and Microsoft. I think the Mobility Plus is the newest one. It deals with BYOD, bring your own device, policies for the workplace. I'm still in high school actually. I just started in 12th grade. It's a self-paced online private school. So you have I believe it's a 10-month block where you can complete your school. You can complete your grade. You can go as fast or as slow as you want. So I just did my grade last week. And after that, I'm also dual enrolled at Countermeasures, and I'll graduate with my associate in applied sciences in December of this year. And I'll probably start at Maryland's online cybersecurity degree. I don't know. Probably keep working out later. I like it there. Who knows? I eventually might want to work for like the NSA, but just cybersecurity in general is interesting for me. Just both the attack and defense side of it, and finding vulnerabilities and stuff like that.
Do you have a girlfriend?
No. Time does not permit for that. like one of those cheap Dells. I forget what the brand, or not the brand, the model number is. One of those, you've also seen like the plastic Dell ones, I guess. And then I moved on. I got a Mac when I was MacBook Pro when I was 12, I think. I was doing that. Now I have a MSI gaming. I like that one.
Okay.